Hello everyone. In this video, I will be giving you brief idea about the line integral, surface integral and volume integral. So the outlines of this video is same, that is line integral, surface integral and volume integral. First I will explain the line integral. The line integral, that means A dot dl over the path L, is the integral of tangential component of A along the curve L. That is, line integral is defined as any integral which is to be evaluated along a given curve. In the figure you can see the path L is given, which is open now, and the small differential length L is given here, and the vector field A is given. For this vector field A and the given path L, the line integral is defined as A dot dl over path L is equal to integral from A to B A dl cos theta. Dl cos theta is basically the tangential component of dl over the path L. If the path of integration is closed, such as if we consider the closed path, that is A, B, C and A, in that case we will calculate the line integral over the closed path, that is integrate over the closed path L A dot dl, and this is also called as circulation of field vector A around the path L. Now for surface integral, let's take a vector field A which is continuous in the region containing the surface S. Then we define the surface integral or the flux of A through surface S. You can see this figure. The surface S is taken and vector field A is continuous over this closed surface. An is unit vector normal to the surface. So number of field vector passes through this closed surface is basically defined as flux, and flux is calculated over this surface by the surface integral A dot an ds, where an is the unit vector normal to this surface. Or we can simply write surface integral A cos theta ds. That means flux of a vector field A will be normal to the surface S. Or simply we can write flux phi is equal to surface integral A dot ds, and it is basically referred as net outward flux of a vector field A through the closed surface S. The quantities like flux density, current density, etc. are the specified over the certain area. Then we take the surface integral to calculate them. Its application we will discuss in the upcoming videos. Some important notes are here. A closed path defines a open surface. In the magnetostatics, for the derivation of laws, we will use this property. A closed surface defines as a volume. Volume integral. Let's take any physical quantity like charge or mass of an object is distributed in the volume. That is, taking the volume integral as the surface is closed. Here you can see this is the surface is closed and it makes the volume, and within this volume the charge rho v is distributed. So the volume integral of rho v is calculated by rho v dv over the volume integral, and the same can also be represented as triple integral of volume v rho v dv. This equation signifies the volume integral of scalar quantity rho v, that is the volume charge density within the closed surface, or you can say within this volume over the given volume v. And we have already studied about the differential volume in the Cartesian, cylindrical and spherical coordinate system. In the Cartesian coordinate system, differential volume is defined as dx, dy, dz, whereas in the cylindrical coordinate system, differential volume is defined as rho, d rho, d phi, dz, and in the spherical coordinate system, differential volume dv is defined as r square sin theta, dr, d theta and d phi. Thank you for watching this video.